All right. This outcome is about identifying if a relation given as an ordered pair, being specific here, is a function. So I have three examples of two sets of ordered pairs, three sets of ordered pairs relationships that we need to identify if whether each one of them is a function or not by looking at those ordered pairs. If you remember, for a function, it could be defined as mapping every element of the domain, and the domain is the values of the x-coordinate in an ordered pair or input, output, and mapping that with exactly one element of the range, and the range is the y-coordinates of those ordered pairs. So if we examine each one of them and see if we're mapping every element of the first set, or the x-coordinate, with exactly one y-coordinate. So we can't map it with two different y-coordinates for it to be a function. So if we have, look at 2. 2 is mapped with 3, 1 is mapped with -2, -1 is mapped with 4, 3 is mapped with 2, -2 is mapped with 5. I don't see any first element is repeated, because if a first element is repeated, that means we have mapped it with two different outputs, two different y-coordinates, and that makes it not a function. So this looks like it's a function because we're mapping every element of x with exactly one y. Let's look at the second one. So there's the domain is 1, 2, -1, 4, 2, and 3. Notice, as I was reading this, I'm looking at the 2. The 2 is being mapped with 3 right here, and the 2 is being mapped with 7. So look at that, 7 and 3. So I don't really need to go examine anything else, because I noticed that the first element was repeated, meaning that it's mapped with two different y elements, which is the 3 and 7. So I know that is not a function. OK, so the third one, we have 3 and -1. So here the domain is 3, 2, 4, 6, and 5. And the range is -1. So 3 is mapped with -1, 2 with 5, 4 with -1. Notice that 3 is mapped with -1, the 4 is mapped with -1. But as long as the 3 and the 4 are mapped with exactly one element, it doesn't matter if it's the same element. So we're OK here. That so far, it's a function. 6 is mapped with 3, 5 is mapped with -3. So it looks like it's a function because we don't have the first element repeated, meaning that the first element is not mapped with different elements of the second coordinate, of the y-coordinate. So this is a function. Let's look at graphing those ordered pairs, just another way to see how we can tell by looking at the vertical line test. Remember, with the vertical line test, we can tell if a given graph is a function. And so if we have a graph, say, so we have this graph right here of a function. It looks like it's a graph of a function. This is a parabola. And if you draw or imagine drawing a vertical line going left to right on the graph, does it cross the graph only once? And for this one, every vertical line will touch the graph once. So I know it's a function. But this function is continuous. However, those relations are not continuous. We just need to plot them as ordered pairs, and we don't join them together. So let's plot those points here for A. 2 and 3. So there's 2 and 3 right here. We're going to see if it passes the vertical line test. 1 and -2. There's 1 and -2 right there. -1 and 4. -1 and 4 is right there. 3 and 2. 3 and 2 right here. negative 2 and 5. Negative 2 and 5 is right here. I'm going to use a different color so it shows here. Negative 2 and 5 is right here. But you could see that all of these points, when you draw a vertical line, the vertical line would not cross two of them. So if we are not sure, we can always plot him and determine that not 2 points are on the same vertical line. So we can tell that this is a function, just to confirm what we've talked about earlier. And so let's do B. And so 1 and negative 3, just graph it. 1 and negative 3 is right here. 2 and 3, 2 and 3. Negative 1 and 5, negative 1 and 5 is right there. 4 and 3, 4 and 3 is right here. I'm going to use a different color to show it. Or did we say 4 and 3? 4 and 3. And 2 and 7. So 2 and 7 is right here. And 3 and negative 2. There's 3 and negative 2 is right there. 3 and negative 2 is right here. Okay. And so as you look at this one, see that a vertical line, you draw a vertical line, it will really go through those 2 points, the 2 and 7 and the 2 and 3. Both of them, the vertical line passes through them, so we know that this is not a function. Okay, and so let's do the last one here. Plot those points, 3 and negative 1. There's 3 and negative 1 right there. 2 and 5. There's 2 and 5. 4 and negative 1. There's 4 and negative 1 right here. Notice that those 2 points are on the same horizontal line, but that's fine. 6 and 3. There's 6 and 3 right here. And 5 and negative 3. So there's 5 and negative 3. Let's use a different color here so it shows. That's 5 and negative 3 is right here. So you could tell a vertical line passes through 1, 1, 1, 1. So the vertical line passes through only 1 point. Sorry. So that is a function, right? So this is a function, passes the vertical line test. See you next time.